Okay, so let's start. Just a brief introduction about the Pie AI Milano Meetup. Pie AI Milano Meetup was created at the end of 2019. It's a part of a global network of Meetup sponsored by Andrew and G. When we create the Meetup, the idea was to gather all the data science, machine learning, artificial intelligence community in Milan to organize physical event. We have organized our first event in a location here in Milan. Then the COVID started to spread all around the world, so we moved to virtual event. And now basically we have members all over Italy, and we have also some member abroad. So sometimes we do like tonight the event in English. We are more than happy to have international guests in our meetup. The organizer of the meetup are me. Let me introduce myself. I am Andrea Gioia. I work for a consultancy firm specialized in data management as a CTO. The other two organizers are two colleagues of mine that work. One is the founder of the company. The other one is the lead data scientist in Quantica, that is the company I work for. Just a couple of words about Deep Learning AI and Quantica, that are the two sponsors of the meetup. As I said, Deep Learning AI is the company of Andrew and G that work in training on stuff related to artificial intelligence. They've created all around the world this network of meetup named Pie AI. Quantica is the company I work for that sponsors my time and the time of the other organizer to create the meetup, organize the meetup, pay for the page on the meetup site. And once upon a time, when we organized the meetup in physical location, pay for the physical location and for the food and beverage. If you are interested, this slide will be shared after the meetup, so there are all the links to get more information about Deep Learning AI and Quantica if you are curious and want to know more. We have a page on the meetup website. We have also a channel on YouTube, so all the events are recorded and shared in the weeks after the event itself. The main focus of the meetup is everything in AI space except the algorithmical part. So we are really focused on how to bring the model from experimentation to production, MLOps, all the part related both to the technologies but also to the organizational stuff that guarantee a success in moving fast from experimentation to production, and also in a way that can be reproduced over and over time with a short lead time. Why we have decided to create a meetup dedicated to this specific topic? For two reasons. First of all, there was already when we created the meetup a lot of meetup in Milan and also in Italy dedicated to artificial intelligence, machine learning, data science in general. But there's no one meetup specifically dedicated on how to put in production the model that we create during the experimentation phase. And this was a problem for us because, as I said, all the organizers of this meetup work for consultancy firms, so work with a lot of customers that have during time insourced the team of data science, and we see every day how difficult it is for this team to bring a model in production. So brilliant people that work on really interesting stuff, but then the throughput of the model that are put really in production is very low. So there is a lot of investment in this market, But at the time, and probably also today, the return on investment in data science for enterprise, I mean, it's still under the real potential of the field. So there is a lot of investment here in Italy, but I think all over the world. But the return on investment is very under the real potential. And the worst part is that also a lot of projects fail to arrive in production. So it's not only a problem of throughput and lead time to move a model from the lab to the production, but it's also the fact that a lot of projects do not arrive in production at all and fail to produce value for the company. So we think that there is an issue here, and it's important to gather the community to talk about this issue in order to find way to improve. The problem was not really on the algorithmical part. Also, we have a lot of problems on the algorithmical part and the technological part, but probably the most critical problem at the time, and some way also today, is related to the process, to all the process end-to-end that allow to bring the model in production. So it's for this reason that we have created a meetup with this specific topic in mind. Say that the organization of the meetup is totally open. So if you want to contribute in any way, you are more than welcome. If you want to help us to organize, you are welcome. If you want to propose a talk, you are welcome. Just drop me an email. You find my email address in the meetup page, and I really more than welcome to talk with you and try to find out how we can work together to make this meetup grow even faster and even bigger. As I said, I think that probably till the end of this year, we are at the beginning. This is the first event of the year, but I think that till the end of the year, the meetup will remain virtual. So we are not going to organize event in place, in location here around Milan. And the organization is a little bit changed. When the meetup was physically organized in a location, we do 3 hours after work with 2 talks, food and beverages. Now everybody feels the fatigue of being online in front of the screen, so we keep short the meetup, just 1 talk, 1 hour plus 30 minutes for question and answer for the one that want to remain connected and have a question to ask to the speaker of the specific event. If you want to help us grow, you can share all the communication related to the meetup when we organize an event, or even tonight, if you heard something interesting and you want to do a post on Twitter or LinkedIn, please use the hashtag that is reported here. It's useful for us to spread the word about the existence of the meetup and growing the number of members. That is also important to create a stronger community, and also to have the possibility to reach and host speaker all around the world that have cool stuff to talk about, like of course tonight. So say that it's my time to pass the ball to Demetrios. So I make you a presenter. Take the stage, Demetrios.
Thank you. Awesome.
Andrea, just make me presenter because connectivity issue. So yeah, I'm going to present.
It's more safe, yes.
Yeah, considering how things have been going for me in the last 15 minutes.
Okay,
so,
a second.
Yeah, no worries. While we're waiting, I can tell you a story.
Or a joke, as you prefer. Okay, Ivan, now you are a presenter.
Okay. Are you sure? Because I didn't receive the pop-up.
No, I'm not sure.
Okay, now, yeah.
It wasn't. Now you are.
Yeah. Okay. So You should see the screen.
Yes, we do.
Wonderful.
Okay, there we go.
There it is.
There we go. So Demetrios,
All right.
stage is yours.
It's all me, huh? Cool.
Yeah,
Well,
yeah.
first off, I'm just going to thank Pie AI for having us here, because this is an excellent opportunity for the teams and the engineering labs and also the MLOps community to get out and speak about what we're doing. And I feel like it aligns perfectly with what you were just talking about, how you mentioned, you showed the graph and everything that Pie and AI can talk about. And the main thing that you can't talk about is the algorithm. And I feel like that lines up pretty well with what we've been doing in the MLOps community. So let's just talk for a minute about the MLOps community, and then I'll pass it over to Ivan, and he'll talk to us about the engineering labs. And today, so you know, we've got Ivan, we've got myself, Demetrios, we've got John and Artem. And there's our faces, in case anyone was wondering what we look like. And so the MLOps community, so we'll get to hear from the guys who are doing the actual engineering labs and the hands-on nitty-gritty dirty work and what their results were in just a minute. That'll be John and Artem. But and then Ivan's going to break us, he's going to walk us through what exactly the whole engineering labs were. And so you're going to get to see what exactly we were doing. And my part of this whole thing is to make sure that you understand where we got together and where we decided to do this, which is in the MLOps community. And so the MLOps community it started about right when the pandemic hit. And that was kind of an accident, but I think the pandemic accelerated it, because it was something that people all of a sudden didn't have the ability to go to conferences anymore, and they were looking for places to share information on trying to get models into production and trying to operationalize their ML. And so we started a Slack community, and we started doing weekly meetups also, but the meetups are less style of like teaching and more of, it's like a podcast that you can join. And so we do those every Wednesday, and we talk to different people. I'll interview people from all over with their different insights and their different thoughts and viewpoints on how they see the MLOps ecosystem. So there's a lot of great stuff coming out of there. And I would say that our main goal in the MLOps community is to share and discover this space together. Because right now, as you all are probably very aware of, it's not so clear, because it's such a new field. We're all figuring it out. And there may be some people that are very advanced because they've been doing it for the last 2 or 3 years, but you don't have anyone really in this field that's been doing it for the last 10 or 15 or 20 years that you can find in software engineering. So that's a huge bonus, because we get to learn together. And it's also, it creates challenges, because we're still figuring out what is the way to go. So that is like the MLOps community in a nutshell. I'm just going to leave you with a few links so that you know where you can find us if you want to join. We have on YouTube, if you just type in MLOps Community, you'll see all of our past meetups. And then we also have it on Podcast Land. Our Slack community is pretty easy to go to. You can see it here on the screen. And then we are on Twitter. We do the Bluebird thing, and that's fun. I try not to get in trouble talking too much shit on Twitter. And then we have a weekly newsletter and a monthly newsletter that you can subscribe to, and it gives you a whole roundup of what we've been doing in the past weeks, because not only do we have the meetups, but we have the coffee sessions that are more intimate, and those are just podcasts, basically. And as one person put it, I think he's actually in here, Laszlo, he was part of one of the teams, because we gave a feedback form to see how we're doing in the community. And I said, what's your least favorite part about the coffee sessions, and Laszlo said, there's no coffee involved at all. So with that, I'll leave you and I'll let Ivan take over.
Thank you, Demetrios. So I'm gonna steal just 5-10 minutes to introduce you at the Engineering Labs initiative, and then Artem and John is gonna show you what you can produce if you join this kind of initiative. So essentially, Engineering Labs, for those who don't know, was announced in August. So we just launched an initiative, and you can find the video here. I just write down on the slide the link, and just to have fun, you will notice that at the beginning the initiative was really tiny, let's say, and my beard was really huge. Now I lost my beard, and the initiative becomes bigger and bigger, and essentially it was possible because the community, the fact that people decide to let's say challenge themselves and join this kind of labs. So we start really really simple with the initiative, with the really basic guidelines. So essentially, the first thing, we decide that this initiative should be for improving our skills. Of course, we really want to push this idea of collaboration, and because all of us were interested in experimenting and testing new technologies, we thought that, okay, let's start thinking how we can use this let's say curiosity to solve challenging problems related to essentially the big picture of engineering stuff, but we then decide to focus on really specific topics like MLOps and DevOps. So that's why at the end of the day, the goal of the Engineering Labs is a kind of mixture data ops, model ops, and DevOps, and all these three disciplines that goes under the operationalizing umbrella. And we start to, let's say, talk with the communities about the common challenges they face day by day. And basically, we collected feedback from the community, and based on this feedback, we decide the content of the labs. So once we, let's say, find out what could be the challenges to address with the labs, we just think about, okay, let's try to involve people in the initiative. So let's create a core squad, and let's say design the team in a way that they can let's say start working on solving these kind of challenges. So in particular, the design of the labs, as I mentioned, is actually focused on machine learning systems. So with the initiative, and John and Artem are going to show you this stuff, but essentially you get the opportunity to explore system architecture, so batch, real-time, streaming, whatever. It depends how do you want to address the challenge. Promote best practice, because essentially each lab is basic on make it reproducible and try to automate all the let's say steps you are going to develop in your engineering in your engineering project. And of course you're going to use different environments. We try to, let's say, push containerized environment because they are easy to replicate. And finally, as I mentioned before, the idea is to test technologies based on the needs that we track from the community. So with that in mind, as I mentioned, collecting the feedback from the community, we realized that the first lab will be related to MLflow and Pytorch. As many of you probably know, this summer, if I'm correct, MLflow team, so Databricks and Pytorch team announced this kind of collaboration, and essentially is a kind of integration between the two tools that, let's say, speed up the deployment story of Pytorch models. And so we were curious about this stuff. And we start, let's say, searching on Pytorch and MLflow, and we find out that essentially Pytorch is catching up another really, let's say, common framework, which is TensorFlow. But except from that evidence, we didn't find out a really, let's say, structured MLOps story. And so we decide that we need this story. And as community, we need to push. We need to find out a possible way to, let's say, deploy Pytorch models. So basically, we based our idea of labs looking at what MLflow and Pytorch communities proposed. So this is the architecture that you can find out if you search from the, let's say, Medium article they post, and also the blog that they have on Databricks. And we suggest to teams to follow this kind of architecture and build on top of this architecture they labs. So this was just a fast introduction of the idea of the engineering lab. If you are interested in, we can, let's say, at the end of this presentation, we can share with you the form that you can compile to join the initiative. But okay, I don't want to steal other times. So I'll ask John Savage to join on the stage and talk and present the first lab they developed.
Thanks, Ivan. Could you make me a presenter so that I can show the videos?
Yes, sure.
Yeah,
yes. 1 second. Okay. There should be on the bottom a button screen.
Yeah,
I
need to turn on something here. Thank you. I need to read. That restarted my. Can you make me a presenter again?
Okay.
yeah, no worries.
We can figure out MLOps, but we can't figure out video conferencing software.
It's not as easy as you would think. That's for sure.
Demetrios knows.
I know.
It needs to. I need to. I'll be back in. It needs to restart again.
Okay, no problem.
Hopefully this is the last time.
Now, give me 1 second because I see you connected 3 times. I have to discover what is the right one. Probably this. Okay, let's go.
Yeah, it works. I can
Perfect.
see you are presenter now.
Yeah. Also, you guys can see my screen.
Yes, you have created a lot of expectation. Go for
Okay.
it.
So thank you very much for having us, Pie AI. This is a really fun project for working on. Great working with the guys, and hopefully this is useful to see what we did. And we'd love to hear your thoughts on what we did. So first, a bit of intro about the team members. So myself, I'm John Savage. I'm a machine learning scientist at Overstock. It's a US e-commerce home store. We have Michel. He's the software engineer at Banco do Nordeste in Brazil. He's a PhD student in love with MLOps, and he was really the organizational heart of the project. He put us all into shape, and he built out like crucial parts of the infrastructure and a whole lot of other stuff to the project. Alexi is the software developer at an ML platform startup, Neuro, and he was the king of automation in the project. He did some stuff in an afternoon, which would have taken me the entire project to do. So brilliant to have him on the team. And Varuna is studying deep learning and is a creator of awesome tool for tracking your ML experiments. So you can track the progress of your ML training runs on your phone. It's really awesome, really intuitive. So check it out at the link there. So as you can see, there's a really great mix of skills in the engineering lab, and the guys set it up really well for that. And no one had any experience before this with MLflow, and a couple of us had some experience with Pytorch, but nothing major. But in general, we were all most interested in learning about MLflow rather than getting into the nitty-gritty of Pytorch and training Pytorch models, much like what you were saying at the beginning, Andrea. Sorry. So just to give you guys a bit of reference in case you haven't used it before, where does kind of MLflow and TorchServe live in this kind of ecosystem? So for reference, here's like a basic life cycle of an ML model from development to production, and MLflow kind of tracks across a lot of this. So they have a tracking server that is really helpful in this experimentation phase. It tracks all your models, and you can evaluate them at the end. Then they have a model registry, and obviously that works as the model registry in this setup. And then they have a models framework, and that helps with standardizing how you save your models, how you can serve those models to a prediction service, and it actually will work as a prediction service itself if you needed to. Obviously, in this particular case, we wanted to look at the MLflow TorchServe the development that had been announced last year. So TorchServe is the prediction serving solution for PyTorch. So we wanted to use the MLflow models integration with TorchServe. So that's where it all fits in and that's where we wanted to tackle that part in particular. So to get started, we kind of just started looking and seeing what they had put up there. So they had this repo for that MLflow TorchServe integration, and they had this examples folder. So we took a look in there and picked one that seemed interesting to us to kind of get our heads around it. And there's one that predicts whether a news article is science, sport, world news, or business. So pretty simple, but interesting enough for us. And kind of using something like BERT, that really kind of would push the limits of a lot of hardware and stuff like that. So we wanted to see what we could do there. So I'll give you a quick run through of that project, just so you guys get a sense of what a good job they have done to make these projects pretty accessible to anybody who wants to get into it. So first thing is you create your Python environment with MLflow and Pytorch installed. Then you just run MLflow run to train a model using their project definition. So that really helps standardize things so that this model is training it run is reproducible. So it's going to train through here and it's going to upload the metrics and models to the server. And another nice thing about this is that they've taken a research project that someone has done and put a thin wrapper of MLflow around it. And I think it's a really good demonstration of how this isn't going to dig its claws into your whole infrastructure. It sits as thin wrappers around your projects, so you can just like pull it away later on when you don't need it. So I thought that was really nice. So once you're finished with the training run here, you can see it put out some metrics there and save the model. So then you could just type MLflow UI, and that would bring up a fully fledged MLflow instance on your computer for you to look at the results of that. What I'm going to show you now is the production MLflow server. So instead of running MLflow UI, you've run MLflow server, and it's a bit more heavy duty, but it essentially shows up the exact same way. So I'm going to give you a really whistle-stop tour of this. So hopefully you can. It's not too fast. But essentially here on the server, you are in the experiments tab. You can see 3 different experiments here. That's just a collection of runs in the default experiment. Each one has a load of information like the parameters such as epoch, the metrics such as accuracy and test loss. And you can compare 2 of those models super easily. You can jump in there, see what's different between them, see what the performance differences were them on lovely graphs. You can go into an individual run and see what all the details about it, the command that was used to run that. And down here at the bottom, the interesting stuff, the model artifacts. So MLflow has defined this standard way of saving models using their functionality. So you can use Spark on them. It's defined in this ML model file that allows you to use it as a Python function, which is used for SageMaker, or use it in Pytorch, use it in TorchServe. So it's defined in a standard way, so you can use it in both. It defines this data folder. That's where the model is saved to, unsurprisingly. And for this model, we've registered it. And so that we can go to the model registry here. That registry is essentially just adding tags on top of those artifacts you've saved. So we've got this BERT model that we've called. Here are all the versions we've uploaded. So 60 versions there. Go into an individual version. You can see the source run that model has come from, tags that are useful for workflow management, and you can stage that model into staging or production. So that's it, whipped through the MLflow UI. But you can see there it's super useful for tracking your experiments and super useful for tracking your models and your model versions. So we were really impressed with it. So now that we've got a model up there in the UI, we can think about serving it. Again, how do we get this into production? So again, you have to create a Python environment, this time with MLflow TorchServe and MLflow TorchServe plugged in. So this was a trickier one to get going than the other one, but once it gets going, it's pretty simple. First, with that environment in place, then you just start up TorchServe. So that's a quick startup. Now it's running in the background. And then we're going to use the plugin, this MLflow deployments create. This is going to package up the Pytorch save file into a model archive file and then register that model in TorchServe, which is going to create a new endpoint. So the archive is created now, and the model is going to be registered now, and a new endpoint will be created in TorchServe. So now that that's created, we can use curl to hit that endpoint and make a prediction on some text like business is good this year. And you can see there that the prediction is business, unsurprisingly. So really quickly, you've taken a model, pulled up TorchServe, and deployed that model into TorchServe. So that MLflow deployments create command is a lot of the work that they had done, and it just makes it super seamless. So that's 5 minutes on what they did. What did we do? What did we do in this project? So unsurprisingly, we're coming to you from the MLOps community. We were more interested in how this would actually work in a real production setting. So we wanted to know, how can we automate this as much as possible? How can we make it as reproducible as possible? How can we collaborate on this across 4 different time zones? And so the idea was take this project and use it as a prototype for our real full-blown production ML training deployment. So as I was making this presentation, I was kind of realized what we were really doing is moving this from a level 0 towards level 1 setup. So if you're familiar with the Google MLOps maturity levels, level 0 is this manual kind of setup, which is exactly what I just showed you there. It's all running manually. I had to type in all those commands. It's all running on my desk, my laptop, or another one other server. So it's super manual, but it still gets stuff into production. So it's it's still MLOps. And what we wanted to do is really move it towards level 1, which is a fully pipelined and automated setup. So what are the things that we needed to do to get it there? Obviously, automation is top of the bill that we needed to do. But another subtle change that happens between level 0 and level 1 is the model registry is that pivot point between ML and ops in level 0, whereas in level 1, the source repository is the pivot point between ML and ops. So that required kind of a different change in mindset of what we were going to do. So when we kind of started this, we had a couple of calls and we decided what we were going to do. And then Michel went away and he built out this awesome diagram, this workflow diagram that helped us massively. And it helped us both because it allowed us to agree on the setup. You know, once he set this out, we could agree or disagree on different components of it. And we had a few iterations on this. But then once it was done, it gave us this nice common language to discuss the project around. So as we were going through and we had kind of different issues around, you know, oh, are we doing this or are we doing that? We had a common language around which we could discuss the project, and that really helped streamline any problems we ran into. So this was awesome work by Michel. So digging into this, slicing it out, as you can see on the left-hand side, the source repository is where it's all starting here, not at the model repository. And so we're imagining here in the setup that a data scientist has done a bunch of experimentation. You know, all that experimentation phase is done. Now the data scientist is ready to commit their new and improved model and get it. Once they put in a pull request, the code is reviewed and merged to master, our automated pipeline takes over. So in step 2, it's going to run an automated training pipeline on our training node. MLflow is going to log all the metrics and the artifacts to the tracking server here in step 3. And then finally, we're going to build a Docker image containing Torch Serve and our model, and that will be wrapped up and ready for testing and deployment anywhere. So in case that was too quick, I'm going to jump into a couple of those bits in detail, so hopefully you can follow through them. So here's digging into the training aspect of it. So we Dockerized this instead of using the Conda environment that the project comes with. So first we build a base image, and that base image contains all our Python environments, and that's super important for consistency between training and serving environments. Once we built the base image, then we built the training image, and now we're just going to run training like we did before using MLflow run, but now with Docker instead of Conda as the reproducibility environment. And again, it's going to do all the same things. It's going to upload all the parameters, all the metrics, and all the model artifacts to MLflow. And then, once it's all up in the model registry, then we can do our Dockerized deployment. And so here we're going to start with the exact same base image that we started with in the training, and that means that our Python environment is exactly the same. We don't have any problems with things not deploying. We're starting up Torch Serve here when we're building the image. That's going to, once started, the MLflow create deployments is going to use that plugin, and it's going to start pulling down the Pytorch saved file, wrapping up into the model archive that's needed for Torch Serve, registering that model with Torch Serve, all in the build process. Now that's done, the new endpoint is created, Torch Serve is stopped, and then we set the entry point to the image to be Torch Serve. So anytime that image started to run its container, Torch Serve starts up and it's ready to make predictions instantly. So now that we've got that the image created, we can push that to a Docker registry, and that's ready to be deployed or tested anywhere we want. So you can see how using this Dockerized setup, we've got consistency and we've got portability built in. So like I said before, now that we've got that that Dockerized deployment server created as an image, we can push that image up to Google Cloud Run. And all of this is happening in Google Cloud, by the way. And we all of the training node, the artifact storage, the registry is all in Google Cloud. But Cloud Run is their managed Kubernetes solution, and it's awesome. You don't even need to know what's Kubernetes. You just build these images and you put them into Cloud Run, and it just turns on. It was really cool. So we push into a development Cloud Run endpoint. We can do acceptance testing on that, like does it do what it needs to do? Does it do it efficiently? If we're happy with that, we can move into step 5, and we can take a tagged model that we want to push into production, and we run a release in GitHub. And so that automatically grabs the correct tagged image from the Docker registry and deploys it to our production Cloud Run service. And so that one's just going to swap out the old image in our production setting with the new one. And so that's all ready to go now, sitting in production, the same one that we had already done the acceptance testing of. So steps 6 and 7 are stuff that we didn't get a chance to get to. That's kind of this automated training pipeline and monitoring node, which I'll talk a little bit about more, but that would get us to a full level 1. So just talking a bit more about automation. So to do all this automation, to do all those steps in an automated fashion, we use GitHub Actions because we had done all we had stored all of our code in GitHub, so it made sense to use GitHub Action for our automation. So those steps that I just kind of walked through in the last few slides, they're all happening through GitHub Actions. And this is all incredible work by Alexei. I thought of him as this like the modern wizard because he knew all these magic incantations for automating these pipelines efficiently. So I learned a bunch from Alexei. So get onto our repo and see what he did there. But you can see if you look through these steps, it's literally what I just did there on the screen, but it's happening automatically every time someone merges to master. And again, like I said, once we decide we want to send something to production, we had a release on GitHub, and that makes this other workflow that takes the Docker image that we want to send to production and deploys it out for a Google Cloud run. But that's seamless; it happens in seconds, really. So what did we learn, I guess, going through all this? By far the biggest pain point we had was the differences between train and serve. So like I mentioned there before, the base Docker image that we created, so that's a base Docker image we created that built out all of our Python environment, and then we used that base Docker image to build our train Docker image or our deploy Docker image. That helped a lot. But a lot of the problems boil down to, yeah, there was always going to be problems there, but a lot of the ones we stubbed our toes on were to do with pickle. So the pickle, we would serialize the model using pickle. This happens inside Pytorch save. They serialize, and then it would deserialize with a different pickle version in the deploy, and it just wouldn't work, and we couldn't deploy it. So Pytorch recommends to use a state dict instead of pytorch.save, and that's just a JSON representation of your model's weights and biases, essentially. And so that's much more portable, and you can plug that into much more settings. So that's coming to MLflow pytorch.save soon, and I think that will be the much better way to go, because that should remove a lot of those foot guns. There are some rough edges around the project docs. So let's say the serve, like I said, the serve environment, that MLflow torch serve, it's a bit tricky to set up. It's finding the right packages to install is kind of tricky, but it's a documentation issue rather than like a fundamental issue. So I think with a bit of, we will go back to them and kind of give them some feedback, and hopefully we can kind of work with them and say what we found difficult so they can improve the documentation. Finally, on the issues, the staging seemed interesting. Initially, it seemed interesting to be able to take a model version and put it into staging or production, but it didn't fit into what we were doing here. We were kind of going this Dockerized setting, so it never made sense to, once we pushed them to production, to go back to the registry and say this was in production. But I think it'll be useful in a different type of setup. But in general, we were super impressed with MLflow. Again, we had never used it before, but the tracking server and the registry are excellent tools. They're really great when like training your models, trying to decide the best ones, tune hyperparameters, and you can see they've tracked all of this useful information to see like what data or code led to a model. And again, like I said, the two projects are awesome. They're in the repos, they're really well put together, and allowed for people who had no MLflow experience, very little Pytorch experience, get up to speed with both technologies within the space of a month. So they were a great resource. Finally, what are we missing? So just to get us to full level 1, what would we like to do? Like, we're missing anything to do with data. You know, we've done no analysis or validation because there's only the data that's there, no feature store, and there's no new data coming back in. So that'll be necessary to get up to a full level 1 setting. We're missing the monitoring node. There's lots of pieces in place. TorchServe has a Prometheus endpoint built in, so you can do performance monitoring, just plug it into that. So it'll give you all the timeouts and the errors and the latencies. But we really need to add actuals, such as user feedback to the web app. So we've got a web app where you can put in and get a prediction, but we've no way for the user to feedback and say that's a good prediction or a bad prediction. So we need that. So So we can say the model is going off and we need to do this continuous training, which would be necessary to set up along with orchestrated experiments, which would never fit into what we were doing. So in summary, it seems like an awesome tool for level 0 teams. Like if I was starting a company from scratch tomorrow, I think this would be a no-brainer to use to get to level 0, because it takes your models, research models, and it very easily gets you them into production all in one MLflow kind of tool. And then it still fits well into a level 1 style workflow. You're going to need other tools to do the automation and the modeling, or the monitoring and all these other things, but it's going to fit right in there. So it'll grow with you. So if you get into it in level 0, you're not going to have to throw it away later. So I think that's good. And I just want to say, like, thanks to the guys like the engineering labs for such a great opportunity to learn a technology that you might not get a chance to play with it at your work. And I also thought it was interesting, like, you may be working at a company that does have a great MLOps kind of setup, but it's nice to start from scratch and build it all yourself and learn all the mistakes and realize why some things are in place there, so that because you get to learn here in your own little sandbox. It was great to work with the team. There's a great set of diverse backgrounds, and we all brought different viewpoints to improve the setup. And I think the repo we've made there could be a great learner resource for end-to-end MLOps projects. So we put that there. It was developed out in the open. All of our mistakes and everything are in there. There's a lot of projects out there for the machine learning side of things, but there's fewer projects out there from like how do we put that into production, and how do we scale out that production. So hopefully there's something in there that's interesting for people to play around with and get to learn what we did. I don't know is it the right thing, but I think there's some interesting ideas in there at least. So thanks to everybody. Thanks to Ivan and Demetrios for organizing the lab. Thanks to the guys Alexi, Michelle, and Veruna for working. Grazie a tutti. And here's all the links to our repo, our wiki, and there's a web app if you want to go on there and play with it.
Thank you very much, John. Super interesting. A lot of questions, but I save the question for the final part. Ivan, I have to make presenter.
Artem. Artem, are you here?
Yes, he's here. At least the list is there.
Hello, can you hear me?
Yeah. Well, really well. Yeah, it's your turn, Artem.
Yeah, thanks for great presentation. Really impressive.
Anyway, Andrea, do you notice that in MLOps community we have all long hair? Demetrios, me, Artem. You see, it's a kind of trend.
Pandemic trend. Yeah.
I like a barber.
So first of all, let me apologize if the drill starts working around me. I'm sorry for that. Hope it will not happen. Also, grazie a tutti per averci invitati. It's a really pleasure to speak to you today. And let me start. So we are the third team of the engineering labs. We are the team of fourth. It's myself. I'm a MLOps engineer. I saw a little bit of MLflow before, like Pytorch, so it was interesting for me to see how it all sticks together. Demetrios, ML engineer, he also was interested in collaboration and taking all the pieces together. Laszlo, I hope you pronounced you correctly. And Paolo, thanks for all you guys. It was a really pleasure to work with you. So as it all started, we had some discussions on how it should look like. Should it be MLflow centric approach or Pytorch centric approach? So should it be like infrastructure first and then you develop the model, or you develop the model and Pytorch and then think how it should be tied to MLflow? And we decided to go the Pytorch centric way, and at the end we realized that we did the opposite one, which I'm going to present now. So the machine learning task for that, we had long time choosing, and we decided to take the Yelp review data set and to implement the NLP model for classification the reviews.
Artem,
sorry.
Could you present the slide? Because you are not in present mode, so we see all your screen.
Sorry.
Perfect.
Sorry.
Thank you.
Yeah, I was just. I'm planning to go out of the presentation to see you some things.
Okay. Sorry. No
yeah.
problem,
Thanks. No problem. Yeah. So for the tools, we used MLflow and Pytorch, and we deployed everything in Kubernetes in GCP. Thanks to Google for 300 free credits, $300 credits. So, sorry. So inside the scope of the project, there was the implement automated training, which is the you press the button and the reproducible training starts in a remote cloud, and all the artifacts which we want to save are saved to MLflow. And then from the MLflow, we can get the model deployed automatically. At the end, we put out of the scope the data pipelines, so any kind of validating, pre-processing, collecting data, and model monitoring. So we just deploy the model. We don't care about its accuracy and etc. So here it is how it looks like. Thanks, Paolo. Great, thanks for the model. And yeah, this is the slide, this screenshot from MLflow. We can see the metrics if it's necessary to show you that. Yes, we use the MLflow run to make the reproducible runs. We store some artifacts in Google GCP bucket, and yes, so we can see the performance of the model just like here. So the next step was we deployed the Kubernetes cluster. So this is the GCP. This is the Kubernetes cluster with yellow borders. These are the servers. The endpoints that look outside of GCP that are exposed, with dashed lines, this is the artifact flow, how the artifacts are moved. With the dots, this is the metadata flow. So basically the flow is that data scientists, by the way, in this free $300 credits in Google, there was no just GPU included, so we needed some other GPUs to train the models, and thanks to Neuro and Nilg AI, these are the companies that provided us with just GPU resources, and so the training pipeline is kind of semi-automatic. It doesn't trigger with CI as the first team's project, but you need to run the script which will train the model, and it will push the model binary pickled file to GCS and the model metrics and other metadata to MLflow server. So basically, and also we don't automate the image building stuff. After that, so this metadata is stored in Postgres internally by MLflow, and after that we implemented a few green microservices which are necessary to deploy the models automatically. So basically, the first server, it implements the Kubernetes operator pattern, which is it constantly looks at the state of at the MLflow, which model is currently deployed, And once it sees that the model is has changed, it sends the it redeploys the model server, which can be MLflow serve or Torch serve or Seldon or anything other. And this model is internally hidden from the outside world. It is proxied by the model proxy, which contains some business logic. In our case, we decided to model the case where you need to log some business logic data, for example, like the average precision of the model or some users information that comes from the web UI, which is stored in Postgres. So and also thanks Demetrios to developing the web UI on top of Streamlit. So this is the web UI that is connected to our model, and we can see. Thanks. We can try it out here. Thanks, guys. We write the text. We say that this review should be positive, and we get the result and the average correctness of the model. So this is basically how it looks like. Yeah, so here you can see the project timeline. We spent like first 2 weeks on picking data set, planning. It was a kind of long process. After the new year, we decided on the project, on the data set. We started developing the model, and we faced a lot of technical issues with Pytorch integrations. For example, and we had during this stage we had to do some step backs. For example, initially we deployed the complex and very cool LSTM model, which worked somehow, which didn't want to work with our with MLflow due to some Pico problems. So we decided to switch back to a simpler model. Also, it was not really clear from the documentation of MLflow serve how to use MLflow model serving. This is like one command. So we decided to implement our custom model server based on fast API, which is of course over engineering, but for our POC stage it was fine. And yes, so the most intense part fit just one day. So here we can conclude that the project was poorly planned, and next time we'll do better. Yeah, so what went well? We had a great time together. We met cool guys and we learned a lot of cool stuff. Unfortunately, we lacked team communication, and we didn't have any beer session, unfortunately. And it took too long to decide on the project, took too long to decide on the plan. And from the very beginning, we lacked the iterative approach, where you define the small and clear MVP, or like step what to do, and then you go to this step, and then once you achieve it, you define the next step. So we at the very beginning we decided to do like really super cool stuff, which was of course not achieved due to lack of time and resources. And the other cool thing we learned is that the approach, research first, then mock up the POC, and then like make it production, then develop it. Yes, this looks like this is so obvious, but I don't know why we face this problem every time, sometimes in some projects. So yeah, and we learned some cool technologies. MLflow, in this example, MLflow serves as the GitOps instrument, which synchronizes the actual deployment with the state of the system. And we did some hardcore MLOps, and yeah, that's it. So it's time for the demo. It's without sound, and I'm gonna comment it. Just give me a second to make it good quality so that you can see it. So yeah, we deployed the Kubernetes. This is how it looks like. Right. So here you can see a few deployments, which is MLflow operator, proxy, and server. Some of them are exposed via external IP. Some of them are hidden. So first of all, we want to go to the model server itself. We port forward it and use CURL to ask the model for the prediction. This review is positive, and also it returns the MLflow run ID. So yeah, this is an example of not such obvious text. It was the one word was changed, but the prediction was classified as it is not positive review. So yeah, now we accessed directly to the model proxy, which is exposed externally. Yeah, by the way, here's thanks to Neuro for giving us the DNS name. Yeah, so this is how it looks from proxy. It returns a little bit more information like timestamp and the model answer and the user answer. And it registers it with the ID. We can see all the predictions made historically to this model, and we can see the this exact model prediction which was made. Yeah, also this endpoint serves the statistics. For example, now it's this beautiful number of correctness rate. Yeah, so now we go to Streamlit to show you the real use case of prediction. Yeah, great job. The correctness is cool. And yeah, now we go to the MLflow model to MLflow server to right. So now we want to suppose we trained a model, and this model is registered here, and we can see that the accuracy is fine, and we want to deploy it. So what do we do? We go to the registered models. We see this 11th version, which is so now. Oops, wait, I lost it. Sorry. Let me go back. Here. Wait, just a second. Yeah, so here we see that the 10th version of the model is in production state and 11th is not. And we yeah, we do some comparison of this model. We see that the best score of the newer model is better, even though the accuracy is smaller, but it's okay. And we decided to redeploy it. So what we do is, yeah, we go to the model page of this version, and we change the tag of, hey, yeah, we change the tag of the model, and we see how the model gets redeployed. Yeah, right now we change the tag, and we go to the model operator logs. This is just the logs exposed, and we see how this model was the deployment was triggered, and we see in Kubernetes that the older model is terminating and the newer one is being deployed. So this is our tag det. Now that during the model redeployment, the model is inaccessible. This is just for 1 or 2 minutes, or maybe less. So we look at the logs of the model here, and we wait for some small time. Let me just switch this quickly. Yeah, this is the model loading, so it loads the pickle model, it finally did, and here we can see that the newer model has responded with the prediction. So the newer model was deployed automatically. Yeah, so this is it for the demo. The next step, I have to do the full screen. Right. So the next steps are to try to defeat the MLflow serve, or to try to play with Torch serve, to use Helm charts instead of bare Kubernetes YAML files, which will allow for other guys to easily use our deployments if needed, to do model authentication. So some of exposed endpoints, for example, model proxy or model itself, they don't have any authentication. Yeah, so defeat the zero downtime rollout. It can be easily done, but it was out of the scope of this project. Yeah, we can use other deployment strategies like canary deployment or shadow deployment and others. No monitoring was here, no HTTPS used. So we can also improve the model proxy logic to authenticate users, to log statistics, and to have a cool UI. And also we would like to experiment with the model to use some recursive neural networks, or to experiment with some different models to check, to see the MLflow in its full grace and force. Yeah, so at this point, thanks a lot. Thanks for my team. You're the best of the best. I mean, yeah, thanks for MLOps Community for this cool opportunity, and thanks for Pie and AI guys to host us. Thanks.
I just wanted to say something real fast, if it's possible, just to give a bit more context, because we started with 4 teams, and I think we didn't mention this. Yeah, 2 of them dropped out, and we had 4 teams of 4, and it was something that we knew going into it. Not everyone was going to be able to finish, but we didn't know who was going to finish. So these 2 teams did it, and it's incredible what they've done. I'm super excited for them, and I just want to say, like, great job, guys.
Yes, it's true. Also, because if I understood well, this is made in their spare time, working on technology that maybe sometimes are not the technology they work with during their ordinary job day. So it's very, very incredible result, I think. In fact, I was curious about one of my first questions, general question, then I leave the space to the other person that are connected. But just one question from my side is that if you plan, now maybe you want to rest a little bit, but if you plan in the future to build upon this result, doing another iteration, maybe to investigating some of the next steps that you have listed in your presentation, because in the next steps, I saw something really interesting to me, and so I'm really curious. It's for Bob, for John, or for Artem, who want to answer.
I think we said it in the slide, but I think one of the most interesting things for us to look at is finishing off and getting that full retraining loop going, and so starting somehow to get more external data coming in, and somehow getting some labels attached to that data, and seeing if our model is drifting or not, and then spinning up a new retraining. And it doesn't have to be perfect, just how to close that loop would be super interesting to us. And the other thing we were talking about was like making it a bit more generic. This is all based off that one single project, so we'd like to kind of abstract out so that we'd be able to drop in, a generic prediction kind of like repo and spin it out into this kind of automated pipeline that we've set up.
So John, you are thinking to investigate something like feature store to versioning data and to provide the same feature in the experimentation?
versioning for sure. Feature store probably not, because we're not going to do any model development. So the features are going to be the features, I think. But I think it's going to be like, how do we get new data in? How do we tag that data? Like, and it could be just us sitting down every day and kind of getting in 10 or 15 news articles and saying, predict, is it good, is it bad on that web UI, and then feeding that back in. And just, you know, again, it doesn't have to actually do a good job retraining. It's just like, how do we even ever build that? Does that make sense?
Yes, makes sense. Can you hear me? Because my screen is freeze now, but
No, we can hear you.
Can you?
Yep.
Okay. Now I have a problem with the screen is freeze, but it's okay. If someone else have a question, it's the time.
Yeah, hello.
Yeah, go on.
Yeah, I just wanted to add that this initiative of lab engineering is super cool, but from our sense, we lacked some governance and some supervision from the very beginning. So it would be awesome to if the organizers could make a, I don't know, like coffee session, beer session together to get know each other better, because it's really difficult to know who has which level of experience, who, like, to distribute the roles in the team. So this would help in the future. And talking about the previous question, what are the plans? I'm not sure if if the organizers are planning to continue the engineering labs. We need to, I mean, we want to do the follow-up, like second lab would be to build something much cooler on top of it. Yeah, I'm totally in. I think it would be great. We would need some sponsors in the infrastructure side, but
but now Ivan, are you working Google, right? So you have a sponsor.
Yeah. Yeah, actually we no, just okay, let's joke about. Anyway, we just we plan with Demetrios what's next with the engineering labs initiative. We just start talking about it, so you probably know soon what we plan, and probably we're going to have new labs with new teams. Let's see. It depends also by the two teams that just delivered these labs now. Maybe they would like to let's say go on and improve what they did. We can discuss about it, but for now the idea is to build from scratch another labs. So that's why I shared in the chat the engineering labs form. So if you want to join, just fill the labs, the forms, and then we can discuss and create new teams.
Perfect. And will be as this one an end-to-end pipeline, or are you thinking to focus on a specific area to investigate a little more? Maybe in this first iteration you work with Pytorch and MLflow. Maybe in the next you have already in mind some specific area or technology that you want to investigate a little more.
Yeah, as I mentioned before, actually the idea of let's say have a lab with MLflow and Pytorch was because we had this kind of vote in the community, and some of them, I mean the majority, just suggest us these two technologies. Anyway, we have to think about the way we decide the topic of the labs. Maybe we can change the rule. We are discussing with Demetrios with this stuff.
Perfect. Yeah. I don't know. I saw that someone else. Sorry, Artem. You want to add something?
Sorry, I just wanted to add, yes, that it would be probably from my personal point of view, it would be like possibly a help for the teams. I'm not sure if it works for others, if the ML task would be fixed, so the ML the data set would be would be defined, and we like did only MLOps and only like infrastructure and stuff.
Bye, John. Thank you very much. Thank you very
Thanks
much.
very much for having me. It was great. We'll see you soon. See you again.
Great work,
Thanks.
great presentation. Thank you. Thank you.
Thanks, everyone.
So I think that if there are not any more questions, I really apologize for the problem, for the reboot. But anyway, that's life, you know. And thank you very much to Ivan and to all the ML community for participating with us tonight. Really great stuff. Congratulations from my side. It was great work and a lot of ideas to think about, I think. And for sure, I covered the maturity model proposed by Google on MLOps automation, and something that I'm going to read as soon as possible. I didn't know.
Yeah, it's one of the main paper about the topic. I think that I don't know how I can pronounce it. His name has a question.
Yeah, I have a small question.
Hi.
Go ahead. Sorry.
No, not a problem. So just a minor question regarding the participants that previously were registered. So should we send the whole this thing once again, or we could just write you an email and say that we previously sent you the quiz?
Yeah, if you want to, you can. I can put the form in the chat now, but feel free to reach me out on LinkedIn or maybe on the community mails, so we can discuss about your participation. Anyway, the form is in the chat.
Okay.
Sorry, I shared. Yeah, here.
But and moreover, if usually I don't know now because we had this little problem, but usually together with the recording, GoToMeeting also save the chat. So probably I can copy all the link that has been shared in the chat before and add as a comment when I publish the video of the recording on YouTube. So you have all the material that Ivan and other guys shared in the chat. But because maybe the video will be published next week, the better way is to contact directly Ivan and ask for more information. It will be faster for sure.
So thank you, Andrea, for hosting this great afternoon about MLOps, and thank you, Artem and John that just left. Demetrios, you are the best as always.
Just one thing for Demetrios, because he said that in MLOps coffee there's no coffee, and in Pie and I Meetup there's no pie. Sorry, so
there's no pie.
The word is perfect as it is.
Okay. Thank you, guys.
Have a good rest of the day. Bye, guys. Bye.
Thank you.